Hi, this is Alex from devstories.eu. GeoDjango and PostGIS, episode 12 of 15. Vector shapes are great when you want to draw a clean line around a city border or pinpoint a user location. But what happens when you need to map something that does not have hard boundaries, like the shifting temperature across a continent or the elevation of an entire mountain range? You cannot draw a polygon for every single degree of temperature. This is where raster data and PostGIS comes in. If you are used to working with points, lines, and polygons, raster data requires a mental shift. Raster data is not made of discrete shapes. It is a continuous grid of pixels, exactly like a digital photograph. But instead of red, green, and blue color values, each pixel holds a specific numeric data point. That data could be rainfall, soil type, or altitude. The entire grid is mathematically tied to the real world through georeferencing. This means the database knows exactly where every single pixel sits on the map. In GeoDjango, handling this data primarily involves two components, the raster field and the GDAL raster object. Raster field is the database column type. You add it to your Django model just like you would a geometry field. This tells PostGIS to allocate space for grid data internally. But you do not interact with the raw database bytes directly. When you pull a raster out of the database, or before you put one in, you use GDAL raster. This is a Python wrapper around the underlying geospatial libraries. It allows you to inspect the raster's properties, like its scale, its coordinate reference system, and the actual values inside its bands. A band is just a single layer of data in the grid. A standard image has 3 bands for color, but an elevation map typically just has 1 band representing height. Consider a concrete scenario. You are building an application for hikers, and you have a digital elevation model of a mountain range. This elevation model is usually provided as a GeoTIFF. First, you define a Django model for your mountain range and give it a raster field. Then, in your Python code, you instantiate a GDAL raster by passing it the file path to your GeoTIFF. Django loads the file into memory as a GDAL raster object. You assign that object to the raster field on your mountain model and call save. Now, PostGIS takes that grid and stores it. Now, when a hiker uploads their GPS route, you can query the database to find out exactly which pixel their coordinates fall into. You extract the elevation value stored in that specific pixel. When you read that field back out of the database, Django gives you a GDAL raster object again. You can ask this object for its width, its height, or its spatial extent. You can access the raw pixel data arrays directly in Python to perform calculations before sending the data to your application front end. Here is the key insight. You use vectors for things that exist at a specific place, and you use rasters for things that exist everywhere across an area. By combining both in PostGIS, your application can relate discrete objects like a hiking trail to continuous environments like the actual altitude of the ground underfoot. If you want to help keep the show going, you can search for DevStoriesEU on Patreon. Your support means a lot. That's all for this one. Thanks for listening, and keep building.